This lesson is on complex fractions. And a complex fraction is essentially a fraction that also contains other fractions, so either in the numerator or in the denominator or both. And what we need to understand or remember is that fractions just mean division. So this question is actually 6/11ths divided by 11/2, because this means division. Or 6 divided by 11 divided by 11 divided by 2. Now, the easier way to do this, of course, is to multiply by the reciprocal of the second. So I'm going to rewrite this question as 6/11ths times, and instead of division, I've changed it to multiplication. I'm going to flip 11/2 over to 2/11ths. At this point, if I could reduce, I would, but I can't. So 6 times 2 is 12. And 11 times 11 is 121, and that's my final answer. So that is actually not complicated, even though the original problem sort of looked complicated. Now this one is a little bit more complicated, of course, because I've got a whole expression as my numerator, an expression as my denominator, and I'm going to have to reduce each one of those. So think of them as just separate questions. Let's focus on the top. If I need to subtract two values, then I need a common denominator. Between 4 and 5, I would find a denominator of 20. So I'm going to multiply my first fraction times 5 and my second fraction times 4. And that gives me 15/20 minus 4/20 on the top. On the bottom, in order for me to subtract, I'm going to turn 4/1 into 16/4, and then of course minus 3/4. So I've done my first step, which is to sort of work towards being able to subtract the values in the numerator and the values in the denominator. 15 minus 4 is 11/20. My denominator, 16 minus 3, is 13/4. Now this is division. I'm going to write it as multiplication. So 11/20 instead of divided by 13/4, it's times 4/13. So I'm changing division to multiplication by flipping the second fraction. I'm going to reduce the 4 and the 20 to 1 and 5, and that's all I can reduce. So now I'll multiply. 11 times 1 is 11. And 5 times 13 is 65. So 11/65 is my solution. Now this is the question that we just did, and I want to show you another method that you use quite often as you get into higher level mathematics. In order to simplify this, I can take everything by the least common denominator of all of the fractions. So looking at 4, and at 5, and again at 4. The least common denominator of this would be 20. So look what happens if I take everything times 20. It's actually going to be very, very nice. So if I take 20 times 3/4, remember that just means 20 times 3, which is 60, divided by 4, which is 15. Nice whole number. 20 times 1/5 would be 20 times 1, or 20, divided by 5, which is 4. For my denominator, 20 times 4 is 80. And then 20 times 3 is 60, divided by 4 is 15. And so now I don't have any fractions in the numerator or the denominator. 15 minus 4 is 11. And 80 minus 15 is 65, and I'm pretty sure that was the answer that we just had on our other page, 11/65. So same answer, kind of a nice little trick. If you take everything by the LCD, that means all of the fractions end up going away. Here's one for you to try on your own. So press pause, do the question, then press play to see how you did. Again, you could choose any method you want here. I'm going to use that shortcut that I showed you in the very last example, but before I do that, I want to rewrite this so that everything is an improper fraction. So I'm going to rewrite 2.5 as 5/2, and I'm going to write 3 1/4 as 13/4. And now I'm going to decide what my least common denominator is. So if I look at 8 and 2 and 4, 8 would be the number that all of those values go into. So I'm going to take everything times 8, or 8 over 1. If I take 8 times 3/8, I would end up with 3, because 8 times 3 is 24, divided by 8 is 3. If I take 8 times 5/2, 8 times 5 is 40, divided by 2 is 20. 8 times 5 would be 40. 8 times 13 and divided by 4 would be 26. If I simplified the top, 3 plus 20 is 23. And 14 minus 26 is, 40 minus 26 is 14. 14 goes into 23 one time with 9 left over, so 1 and 9/14 is the correct response. Again, you could have chosen a method other than the one that I chose, but you should end up at 1 and 9/14 no matter what.